Hello everyone, this is Ali Reza. In this video, we will do our parallel node. Now remember, from this point forward, I don't have any, sorry, but I don't have any nodes side by side my development environment. So it's an adventure for myself, and I hope you like it. Then, well, for the parallel node, basically, parallel node will tick every one of his children in one tick, regardless of the result. Okay, but then it will accept a condition to see if it should return failure or success. The conditions can be changed, so I will add an enum somewhere, not on the base because it's not related to the base, so I will add it here. I will say an enum, yep, and no, I will create a namespace for that, enums, and enum, and that enum is a parallel node conditions. Parallel conditions because node is irrelevant. So what are the conditions is first failure, first success, all failure, all success, num failure, and num success, and then well, let's do this failure count, success count, failure ratio, and success ratio. So obviously, if we encounter our first failure, that, well, these two does not mean anything, Okay, remove them. So if we all failed, that is when we return success, because this is the condition we want. Or if we all succeeded. If the failure count is some predefined, for example, we have 5 children, if we failed 3 times, or if we succeeded 3 times, or if 20% of the children return failure, for example. Okay? So that are the conditions that we want. Now, the parallel node itself is a composite. So class parallel node, and don't forget BT. And you are seeing me doing stuff on the fly. BT base node, yeah, come on, capital N. And it's near 4 a.m. So if you see something blue in my face, don't blame me, blame the timing. So composite, add a class, BT parallel node schema, and it is like that, you see, blown in my face. BT base node schema and node. So for parallel node, well, obviously we need to put the initialize there, and obviously we need the draw node properties because we need to set some things. Okay, and here we will have a public parallel conditions, and we call it conditions, or maybe success condition. Then we have our overloads for initialize Initialize, yeah, tick reset. Then that's it. So in initialize, after the base, well, we will have an input, we will have an output. The only thing that we want is setting our success condition equals to, I will say, which one? Which one makes sense more? All success? Yeah, let's go with all success. That doesn't change anything. It's just I'm thinking about the condition that we may use the most. And of course, this needs to be a serialized field. Then we will have a serialized field of public, not public, private, int success count. And failure count. Then what? The ratio is the numbers divided by total. That's okay. I think that's it. We will come back to this if we don't have anything. So we said that we will tick everything. So for outputs at 0 dot connection nodes dot count var, and we say node. Now remember, why are you yelling at me now? Int, because int does not contain a public definition. Get enumerator. Ah, come on, count. Derp. So we need to say if our inputs that is null or empty, or inputs of 0 that connection nodes that is null or empty. We want to set our state equals to error, and we return the base dot ticked, not ticked, tick. So here is the conditions. Here, well, basically we say var, no, evaluation state, child state. I don't want to create time and time, so we say child state equals to node.tick. Then we say if child state equals to success, not that, equals to success, then we say success count plus plus, else if child state equals to failure, then we say failure count plus plus. But what if the child returns error or it returns running? We say if, well, I will do it on top. If child state equal to error, then first we set our state equals to error and we break out of the loop. So it will come here, okay? And here we say if state equals to error, do the early exit, so return base dot tick. That is where the rest of the logic will come, okay? If child state equals to running, we set our state to be running. So here we say if state equals to running, then again return the base. Okay, but we say here, we say active the parent graph dot active node equals the child, the node. Okay, so after all of this we have our ratios. So we say switch on our success condition, and we say case of all failure. And then we break. And I like my cases to be one back. Okay, so we say if failure count equals to outputs at index 0 dot connection node dot count -1, then we set our state equals to success. Else state equals to failure, because we didn't meet our condition, and yes, we can convert it to ternary. So we get this, and we paste it. If it's all success, and here we want and we say success count should be equal to 0. So if in this case success count equals to that and failure count equals to 0, that's our second condition, then we have a case of failure count break. This is simply say state that failure count equals to something, and that something is not defined yet. So we will have a serialized field of public int count and a serialized field of public float ratio. So if our failure count equals to count, we say evaluation state success, otherwise evaluation state of failure. The case of success count, yeah, state equals to success count, not that, success count equals to our count. If that is the case, evaluation state success, otherwise evaluation state failure. Then we have ratios. So case of failure ratio break, we say var ratio equals to, and this is our failure ratio, so failure count divided by, and I need to cast one of these guys to float, so float that, or let's divide the that with a cast to float of this guy. So if our ratio is greater than or equal to our other ratio, the capital one, if that is the case, we return evaluation state. Then we say state equals to success, and I forgot ternary apparently. State equals to ratio greater than or equal to the capital ratio. Case evaluation state success, otherwise failure. And we have that for our success ratio. And here we say success count. There we go. And I can take this guy out of the switch, and I will say float that and remove the bar. There we go. So any other thing remained? Let's see. All failure, all success, keep. No, not that. Keep this guy on the second monitor. So all failure, all success, failure count, success count, failure ratio, success ratio. Okay, so we have all of that. And that's it. That should be it in theory. We will see if this will work in near future or not. Now, this guy. Oh, take a note from one of these things like this. Not that, the schema. Okay, we have this. Paste. Now, the icon is parallel that we don't have yet. The show name is parallel, and here we need to change. Well, navigate negative mode is the same, so we say parallel node will take all its children at the all its children in the same at the same time. At the same time, no threading. That's critical. At the end, it will return success. Here's the trick. Hit enter. And it will return success based on the condition setting for the node. And let's think if that is enough. For example, if you set the condition to all, and here I need backslash that, all failure, at n, that, it will return success if all of the children return failure. And that would be it, I think. Now, in draw properties, we need to draw our stuff. We need to draw these three. But first we need to draw this. Then on the case of this guy, we will draw one of the other ones. So we have a pop-up. After the base, we will say GUI layout space of 5. GUI layout dot begin horizontal. GUI layout dot end horizontal. Copy this one more there. Now this one is a GUI layout dot label of condition. Then we say cast to BT parallel node our related node dot success condition equals to editor GUI layout, I hope, dot not enum mask field, enum pop-up. There we go, of the same guy. Boom. And now we simply need to typecast this to what was that? Parallel conditions. That's it. Then here we say if this guy equals to failure count, or it is equals to success count, we want to do something else if this guy equals to the ratios, so failure ratio, or equals to success ratio. We need to do other things. Okay, so here well, first of all we have a label, so the label is out. The label is here. We are in count, so we say count. In here we are in ratio, so we say ratio. And in here we typecast to BT parallel node related node dot count equals to editor GUI layout dot integer field, and we basically want to count that. And here we have almost the same thing, but we have a ratio that is a float with the ratio. Now the only thing remaining is this guy. So create other field inside our resource, and this is our read only equals to the name. Now what was the name? I think it was parallel. Yeah, Control C equals to parallel dot colors from texture with sending in the manifest. There we go. And let's hope it works. So coming back, we will have our it won't. Here. Now parallel, I will add it after condition. So BT parallel and parallel. Build, coming back. Now let's have a parallel node and argument node name bt. Parallel node is not mapped as a node. bt parallel. Oh, yeah, sure, it's not mapped. Parallel node, yeah. Yep, that should work. Build. So parallel, there we go. And all success. And why am I getting this guy null referenced? Where is this guy? Node 81. Didn't I fix it? Node 81. That's the same condition that we had. So if child that is if child equals null, simply continue. Didn't I said that before in few videos before this? I remember that. I really remember that. Okay, so if parent equals null, please continue. Not const, continue. Thank you. Build. So that was something I didn't expect. So that's it. Okay. Now it's set on all success. Let's go with failure count. So we see the count. That's it. Failure ratio. Success ratio. So let's go with all success first. Now we have success. And I will go with 4 nodes. Maybe 5. Yeah, let's go with 5. Okay. So what the GUI error? Let's see this. More GUI clips than you are popping. Where? Huh. I don't know. Come on. There we go. Okay, let's reset and let's tick. So it returns Earth. Why are you returning Earth? Huh. This is the parallel node. Its outputs, element 0, connection node has all of these guys. Okay. So why are you errored? Reset. Huh. Let's take a look. Yeah, this happens a lot when you do R&D in front of the camera. So if inputs is null, Who said inputs? It should be outputs. Yeah, of course it would. Errored out. So, and it returns failure. Why it returns failure? We are all success, we all succeeded. So let's see. If all success and success count equals to this count minus 1. Well, at the start, right here, let's reset them. So success count equals to 0, no, not that, equals to 0 and equals to failure count. That. And at the end, please do this. Debug.log our outputs 0 dot connection node dot count plus dash plus our success count plus dash plus our failure count, so that I get a debug. Five 550. Oh. Who said minus 1? 4:18 in AM. Yeah. We are not indexing, we are getting the count. Wow. I'm derping a lot. Okay. Remove every minus 1. That's the trick. So clear, reset, tick, and it is returning success all the way up. I'm not happy with that. It shouldn't return success all the way up. We are just setting our stuff and then returning the base. It should have waited for 1 tick or 2. Meh. Let's see, all failure. So right now it should fail. I said all failure. And it, oh wait. We don't want to do this here. Okay, build. So when I'm resetting, it won't reset its state, okay? So tick, failed, okay. Now, if I negate all of these guys, it should return success. And it does, okay? Now, I will go with failure count of 3. So 2 of them should succeed, the rest should that, and that's it, okay? Make it 2 and it should fail. There we go. Now number of success 2. Now it should succeed. Good. If I make it 3, now it should fail. There we go. Now I will go with failure ratio of 0.25. Make it 0.2 so that it should succeed now. There we go. And it should fail now. Now, actually, it should succeed because it's greater than or equal, but now it should fail. Oh, come on. 4 to 1. Yeah, okay, 25. Now it's failing, okay? So if I set its success. Now it should fail. Yep, now it should succeed. There we go. So the only thing that I'm getting confused about is why this guy is sending it upward. So let's break it. Let's select these guys and move them. Not like that. Okay. Select them, move them down. Select them, move them to the side, and have I don't know, sequence node. Why not? That, and have a success here. What I want to see is that the first tick, it returns success, it goes back up. Yeah, that's correct. Okay. Yeah, that's correct. Okay. So we have our parallel node, guys. We have all failure, all success, failure count, success count. That's all there. So what did I change? First of all, we don't need to reset the state at the reset because, well, we don't need to reset it to all success every time. And we removed that -1 on the counts everywhere. And now we don't need this debug. So that's our parallel node. Hooray to that. Also, we added this if child equals null, if parent equals null. For time being, I see them being correct. And I remember doing this once in previous videos. I don't know what happened. I didn't touch this guy, I swear. So we have the parallel node. And can see within the instance. Well, let's do the random probability next, because that's again one of the nodes that doesn't need anything extra and it's easy. So until next episode, have fun everyone. Bye bye.